Okay, starting on problem 16, it tells us to simplify, and this little dot in the middle tells us that we're going to multiply. So I'm going to take care of the numbers first. So 2 times 4 gives me 8, and then on bottom 5 times 9 gives me 45. 8 over 45 won't simplify. You can try to type it as a fraction to see that. And then to do the other part here, we got to worry about all the variables. We've got a times a here. And remember, when you multiply variables, you add exponents. Okay, you have to, x's go with x's, a's with a's, b's with b's, c's with c's, etc. So I've got a to the 8th times a to the 2nd, which gives me a to the 10th. And then on bottom, I've got a to the 5th and just a, which is basically a to the 1. So that's a to the 6th. And then on top, I've got b to the 5th, and then b squared. And that's all from adding them, 2 plus 3, and then 1 plus 1. And then from here, because these numbers don't simplify at all, 8 over 45, I'm just going to leave those as is. And then I'm going to cancel out as many a's as I can. So 10 minus 6 gives me a to the 4th on top. 5 minus 2 gives me b to the 3rd on top. 17 says perform the following operation. Operation, once again, is multiplication there, and express in simplest form. So basically, what you're doing when you're multiplying here, like here, is you're going to multiply as much as possible, make it one big fraction, really, and then factor out using different methods and factor out using different methods and then simplify from there. So, for example, let's just combine this into one big fraction on top. Okay? So I've got x minus 8 on the first one. And then this is difference of perfect squares. Difference of perfect squares. Okay? So I'm going to set up a parentheses with a plus, parentheses with a minus. That's just how, we have parentheses. That's just how I remember it. When I'm doing difference of perfect squares, I just always set up those two parentheses with a plus and minus. And then this first part here, x squared, is going to give me, I'm going to take the square root of both of those and split them apart. So x in front, and then I take the square root of 25 here, which is 5. So 5 and 5. So x plus 5, x minus 5. Then on bottom, this is just going to be the x method. What adds to the middle, and then what multiplies to the end. Hint, hint, you already seen this like in an earlier problem. So I'm going to have, it adds to negative 3, multiplies to negative 40, negative 8 and 5 does that. So that's going to give me x minus 8 and x plus 5. And then I've got this x plus 9 at the end, okay? Once we make it one big fraction like this, all I'm going to do is cancel out as much as I can. Do I have an x minus 8 on bottom and top? Yes. Those are gone. I have an x plus 5 on top and bottom. Those are gone. And then what I'm left with here is this. So I'm going to rewrite that, x minus 5 over x plus 9, and that is your answer. 18. It says, combine the following fractions and express in fully reduced form. So all you're going to do is look at what the operation is. I'm going to add. So I'm going to add the x's together. So I'm going to have negative 11x. Then I'm going to have 7 plus 5. And it's going to give me a negative 11x plus 12 over 7. And really here, 11 and 12 don't have anything in common. So there's nothing I can factor out and cancel out. So that is my final answer. Okay. And it says solve for x on this one. And anytime we have a proportion here, which means that I have a fraction on the left and right of the equal sign, what I'm going to be doing is my little cross multiplication or butterfly method, however it is you remember it. So I'm going to multiply those together. This is kind of like a crooked butterfly. So 9 times 5x plus 8 equals 4 times 5x minus 1. And the reason why I'm writing in parentheses is I have a monomial, just a regular number, times a binomial, and it needs to be multiplied by both by distributing it. I'm going to do that there. So 9 times 5 is 45x plus 72 equals, distribute the 4 out. So I've got 20x minus 4. And then here, there's multiple ways you can solve this. Usually the way that I do it is I always get rid of the x on the right. So minus 20x minus 20x, which is going to give me, that's going to be giving me a weird number. So 25x plus 72 equals -4. Then I'm going to subtract 72 on both sides. That gives me 25x equals -76. Divide by 25 on both sides. And if I put this in my calculator, I've already wrote the answer, but let's put it in my calculator and see what happens. So -76 divided by 25, okay? That's not too bad of a decimal, but usually we want it as a fraction, so I'm gonna go press math, enter, and that's just gonna give me -76 over 25, which is my final answer here, okay? Give me 1 second to check this. Check my math. -304 plus 8. 5 times -3.04 minus 1. Divide these. Yep, math checks out. And then we have 20, which is where the regular algebra final will end. The 4 problems that are additional on Excel will be in the next video. So let's look at this together. It says the graph of y equals f of x is the parent function is the solid line here. So right here, that one, okay? Which function represents the dotted graph, okay? Let's think about what we did here to get here. So my vertex moved to the left 3, and then it moved down 4, okay? So when I look at that, what I'm looking for is, how do I do that, okay? Remember, the number at the end moves it down 4, so I'm looking for a -4 at the end, so that eliminates these two. And remember, my big key is that parentheses are liars. So you can see here what I'm talking about, that there's a -3 where the vertex is, but instead of -3, because parentheses are liars, I'm going to have a +3, which is right here.